So here we are. We're looking at Chapter 4, Global Climates and Biomes. This is a really big background chapter because it's going to talk about a lot of the things that drive environmental issues and functions across our planet. So first things first to understand about global climate is, what is climate? Module 9, here we are, unequal heating of the Earth. Climate is the average weather conditions for a region over a long period of time. When you think about Northeast Ohio, our climate is we have warm summers with a good amount of rain. We have mild falls and springs, and then we have cold, still wet winters. Versus, down south, maybe you don't have quite the moderate temperature that we have. It gets hotter down there, and they don't have the winter. So that's our climate. It's our average conditions over a long period of time. If you look at the weatherman, what they talk about, the weather people, they give you data of averages for the last 30 years. And they even keep track around here, at least since the Civil War, we've kept track of the weather. The difference is the weather is short term. The weather is like today. Okay. The weather affects the way you dress today. The climate affects the plants you can grow in your yard. Okay. And when you're talking about weather and you're talking about climate, you need to know about the layers of the atmosphere. And the big thing to understand is our weather happens in this bottom layer, the troposphere. The troposphere only extends 16 kilometers up. And like I said, all your weather happens there. Most of your air traffic happens in the troposphere. After the troposphere, you can see here there's the ozone layer. And the ozone layer is, of course, very important to us because it blocks a good portion of our ultraviolet radiation that bombards us daily. And then above that is the stratosphere. So most of what we're going to talk about is in the troposphere and stratosphere. There's a little bit of stuff that happens in the mesosphere and then the thermosphere. Pay attention to this red line. So in the troposphere, this is altitude and this is temperature. You're going to go from, surface temperatures all the way to negative 60 at the top of the troposphere. It's very cold up there. But then you'll notice, oddly enough, it warms back up here in the stratosphere. Then it cools way off, and then it gets hot. Part of these things happening is because once you get higher up in the atmosphere, you have fewer particles. And so those individual particles carry a very high temperature. It's not that you're so much going to get burnt if you're out there, but if you measure the energy of those individual particles, they'll be much warmer. Okay. And then the exosphere, you can't really even, that's kind of, you left space, or you've left Earth and you're in space at that point. And one of the biggest driving factors of all of our weather is the amount of solar energy hitting the Earth, and the fact that it hits different amounts in different places on the planet throughout the year. So this picture is during our summer, and you'll see that the North Pole is getting sunlight, but it's at an angle, so it's not strong sunlight. Whereas down here in the tropics, they're getting direct light. And in the southern hemisphere, it's also not getting it very much. This would be their winter. And it's this unequal distribution of sunlight that drives weather. It causes the oceans to do what they're doing. It causes the land masses to heat up and cool off appropriately. And that's what drives the energy in our planet. But there's other things to consider. One of them is this idea of albedo. Albedo is the percent of incoming sunlight that is reflected. And different surfaces will reflect or absorb differently. So if you look here, the clouds, they reflect a bunch of light. Okay, fresh snow reflects a bunch of light. Sea ice reflects a bunch of light. Crops and grassland, they don't reflect that much. Forests don't reflect that much. Asphalt does not reflect very much. Water can reflect. Now, it says depending on the sun's angle. If you're at the equator, it's hitting pretty straight on. You're going to absorb a good amount of it. If you're up at the pole, it's going to bounce right off. The average Earth's albedo is 30%. And here's where it matters. you get a positive feedback cycle with albedo sometimes. Back in geologic history, 700 million years ago, for say, the Earth was in a bit of an ice age. In fact, some geologists will call it the snowball Earth, where a very large portion of the planet was covered in ice. And so if you're covered in ice, you're 80, 95% reflection, 50% reflection to 90%. And so you get this feedback loop where we're reflecting the sunlight, which means we're not warming up. And so if you're not warming up, you get colder. And if you get colder, you get more snow and more ice, and you reflect more light, and you get colder and you get colder. Some geologists would predict that the only reason we ever came out of the snowball Earth was because of volcanoes. So volcanoes welled up underneath the ice sheets, burned a hole through them, and spewed ash all over the snow. That ash was like asphalt, right? It absorbed most of the light and helped melt the snow. And the only reason we got out of that was because of volcanic activity. And so you can see how melting the ice sheets will affect the albedo of the Earth, and it affects the amount of sunlight we absorb or reflect, and it can affect the climate. So albedo, it's like one little idea, but it's kind of a big idea. Okay? And this encapsulates Module 9. And that'll be the end of this particular recording.